video you watch and the simulation I sent you, the video is trying to show us where a vectors are being resolved as a result of a car that is pulled by a little boy, okay? So if you check the simulation, you can practice what I'm going to explain to you today, okay? Alright, so if you check, you have the resultant of more than two vectors. So the other day we are resolving vectors in components, but today we are going to resolve more than two vectors, not just two different vectors in components, but this one about maybe 4 or 5 or 6 vectors, okay? Alright, so you can check the objective of today to know what we are going to study, which is resolve a vector into a given directions. Resolve any number of vectors into two components at right angle to each other. Do you hear? Then the second point there is solve simple problem involving resolution and addition of vectors using analytical and graphical methods. So let's start. Now you have a vector like this, unlike the one we had last week. So you have something like this. So the arrow shows vector, okay? You call this from F1. This is your horizontal, just like your Cartesian plane. So this is 1. You call it theta 1. Then you have this one here, which is F2. Okay? So you made an angle with horizontal this way. You call it your theta 2. Then you have another one here, which is your F3. So you still made an angle again. You call it your theta 3. Then you have another one this way. You call it what? F4. It made an angle. You call it what? Theta 4. Right? So having gotten this thing now, you have to now make it to be in two different components. That's the essence of what we are trying to do. First and foremost, remember the last one we did is involving vectors that looks like this. Okay? That looks like this. Assuming this is your S axis, your Y axis, so this is going to be your F of Y, this side is your F of S. So having this now will give you your F resultant, okay? So if you can, we can call this alpha or theta or whatever you want to denote it, but it means an angle is made. So you remember how we resolved this one the other day, where we now say resolving this way. Remember, we can say resolving horizontally is Fs equals to what? Fr cos, because of this angle here is alpha. But for Fy, which is this side, you remember what I did using SOHCAHTOA, right? We are not going to repeat the same. So Fr sine alpha. So all you have to do is, when you just put the you just change the sign. Only the sign and cos is what you have to change. If you change it, then you can go on. Alright, so you remember what I told you again last time, that after that you can take this one here, put it here to make an angle that looks like this. To make an angle. So it means when you put it here, it will have something like this, which have this. Then this one coming this way will now have this way. Then this one that is already here, let me make it well. Okay? It will be like this. So it means that you take this one this way. Then this one that's already here will now be this way. Then it will be F of R this way. You can call this one your alpha to denote your angle. Okay? Or you call it theta or anything. Then this one it can now be your F of Y, which is this one coming this way. Okay? Okay? Alright, so it can be this way. So if you do it that way, remember what I told you, that you can use Pythagoras theorem to now know the particular angle, the final resultant, using something like this, F of S squared plus F of Y squared. If you do it with Pythagoras, that's Pythagoras theorem, you find the final distance. So now, we want to add all these vectors, okay, into components. So I want to resolve. I've shown you that if I resolve this, it will look like this. Then from here, I can get to this final stage, okay? Alright, so now let's start. Now, F of S, I want to resolve it all in components. So it will look like I want to take this man this way, and this way. Okay? Alright, so look at what is going to happen. Taking it this way, it means that I'm going to do something like this. Let me put it this way. So I'm looking at this angle, okay? Then the next one, I'm going to look for the whole angle here. Then the third one, I'm going to look for the whole angle here. Then the fifth one, I'm going to look for the whole angle here. Okay? So you can call this one your 1, your 2, your 3, your 4. Okay? So So now let's see how it goes. The first one, I'm going to resolve all this way, which is going to what? Because we are resolving horizontal like we have here. So it's going to be f of r. So f of r is that f we are resolving, this man here. This one here, we have f1 cos, the angle here, for the f1, cos theta 1. Okay? Now plus, for this one now, okay, maybe I'll clean it so that you can see how I'm doing it, or whichever way. Okay, for this one now, which is the second one, this second one, so it's going to be from here down, So the whole angle here is what I'm going to look. So I'm going to say f2 cos, the whole of this, I don't know how to get the whole of the angle here. So I will say, since we have theta 2 here, and the whole of this is 180, angle of a straight line. So I will minus theta 2 to get the whole of this. Okay? So it will now be 180 minus theta 2 plus, if I want to go for the third one is this one, okay, f3. So I will say f of 3 cos the whole angle here, down here. So how do I know the whole angle here? I know that from here to here is 180. So if I add theta 3, it will now be this whole angle here. Okay? So it will now be 180 plus theta 3. Okay? Now you can say plus, for this one now, the whole angle here down to this place. Okay? So the whole angle here is going to be f of 4 cos the whole angle here. How do I know the whole angle here? Since I don't know this. So what I'll do, I'll take the whole angle all through here, which is 360 degree. Okay? The whole angle. So which is 360 degree. Then now 360 degree, if you minus this one, it will now give you the whole angle here, which is what? 360 minus theta 4. Okay? That means if I now solve this thing, assuming we have real values, it will give us the resolution in what? Horizontal axis. So for the vertical axis, which is f of y, is going to be the same thing, but for the sake of here, you're going to do f of 1. You can just change the sign. I'll show you why the sign was changing. Only the sign was changing, but the whole values are the same. Sine, this one is going to be 180 minus theta 2 plus f of 3 sine in bracket 180 plus theta 3 plus f of 4 sine in bracket 360 minus theta 4. Okay? Now the reason why it is like this is because we use the same way. Just like in this case here, I told you that this and this, the only thing that was changed is cos and sine. Just like in this case, okay? And you remember how we did the resolution here, okay? Good. So that's what we did here. We got this point. Now, having gotten this point, now we have resolved this thing in components, which is okay for us. But if we are to have a real value, you remember what I told you, that this whole thing we now use Pythagoras theorem, which is this man, to find the actual direction of the vector, because vector is what? Something that has magnitude and direction. So you want to get the actual direction, assuming there is a bullet here, many forces acted on it, so it will take a particular trajectory. Okay? So to know the actual direction, that's what we can now use the Pythagoras theorem to finalize it. Okay? You know all those ones. Okay, now let's check a thing like this, like I showed you this. Now, if we are to get the angle, for instance, it has come to this point of Pythagoras theorem, which you all know. Now we need to now find the angle, which is this angle here, because after we resolve it, we have an angle. We want to know the angle, okay, which is what? Use tan according to Socrates, toa, opposite, which is opposite over what? Hypotenuse. So in that case now, the opposite, like let me use this one to resolve it. Opposite will now be what? F of y over hypotenuse, which is what? F of, let me do it this way. Yeah, f of y is equal to what? F of s. So in that case now, you can now say, if you like, you can say, remember it is tan alpha. It is tan alpha, okay? Tan So you can now say, since tan alpha is equals to, which is tan alpha is equals to what? Fy over Fs. That means alpha itself will now be tan inverse. When tan crosses sign, it will be tan inverse f of y over f of s. Whatever you find, that will give you the angle. For you to know the particular angle where, assuming you place that thing, that is the angle it can use and get to the point where it's going. Alright, let's do some calculation. The first one, calculate the resultant of 5 coplanar forces of values 10 Newton, 2 values of 10 Newton, okay? 10 Newton, 12 Newton, 16 Newton, 20 Newton, 15 Newton, acting on an object at O, okay? So if you are to draw that coplanar forces, let me show you something like this. It looks like this. So if we have this, for instance, we have this. Then we have another one. This one is 10 Newton, which is the first one. Then we have, let me put this something like this. Then we have another one like this, which is 12 Newton, the second one I told you. Okay? And it made an angle of what? 15 degrees with the horizontal. Then we have another one that moves this way, which is, and it made an angle of 40 degrees with this side of horizontal, which is what? 20 Newton. Okay? 20 Newton. Then we have this one, is a vector, so it has 16 Newton. I hope you are seeing the board, right? 16 Newton. Then we have another one like this, and it made an angle of, let me say, okay, this one made an angle of 30 degrees. 30 degrees, okay? Okay, so this one is 15 Newton. 15 Newton. It made an angle of 30 degrees to the vertical, okay? Alright, so if you have something like this now and you are to resolve it, remember what I told you. If you memorize this and know how you'll be able to arrive at that, you can easily solve it. How do you solve it? You resolve in horizontal direction and you resolve in vertical direction, which is S and Y direction. So I'm going by F of S, okay? F of S, which is what? The first one. So in this case now, because the first one lies directly at the horizontal, okay? Which is the value 10 cos, the value it has, the angle it made with the horizontal is what? 0. Plus, the second one is what? 12. Remember, I told you, if you like, you can make this one like this. You can make it this way if you like. You call this one your 1, okay? So the whole angle is made with this horizontal, which is 12 what? Cos 50. Plus, this one now, we now make the whole angle here. Okay? If you like, you call it your 2. Okay? Which is what? 20 cos. The whole angle is made here. To know the whole angle it's made here, we don't know it because of there's no angle here. We move to this way, which is 180 degrees. So the angle on the straight line is 180. If you minus it this 40, the remaining is the whole angle it's made here. Okay? So you now have something like 180 minus 40. Okay? Now we now have plus this one. The whole angle it's made here. The whole angle it's made here. Like this. Okay? Which is the third one. The whole angle it's made here. So you can now say 16 cos. The whole angle it's made here is what? 270. We know that angle on this side is 270 to that side. Plus this one. The whole angle it's made here. The whole angle is made here. If you like, you call this one 4. The fourth one, okay? Which is 15 cos. The whole angle here, how do you know it? This from here is 270. Then you add this part, that is the whole angle made here, which is 270 plus 30. Okay? Now, our f of s is going to be equals to 10 cos 0 plus 12 cos 50 plus 20 cos 180 minus 40 is 140. 140 plus 16 cos 270 plus 15 cos 270 plus 30 is 300. Okay? Now, if you press all these together, it will give us a value, right? If you press all of them together, it will give us value, which is going to be, if I press it, it gave me something like this from f of s. Everything is going to give me f of s to be equals to 9.89 point something 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 in the calculator, okay? 9.89 point something something, okay? Alright, so I have resolved this way. Now, in resolving the other way, which is the vertical aspect of it, aspect of it is what we are going to resolve. And remember that these whole things must have a unit, okay? So it means that this one, whatever we get, we will put it in Newton because of the force, okay? So now let's do the vertical aspect, which is Fy is equals to, please, no need of trying to think too much about it. Just this whole thing you see here, repeat it but changing sign, okay? So I'm changing it, which is 10 sine 0 plus 12 sine 50 plus 20 sine 180 minus 40 plus 16 sine 270 plus 15 sine, then this one is 270 plus 30, okay? Which brings us to the second stage. F of s is equals to, which is 10 sine 0 plus 12 sine 50 plus 20 sine 140 plus 16 sine 270 plus 15 sine 300, okay? Now, if you now find the whole answer, you see that this one is going to give us something like this. It's going to give us f of y equals to minus 6.94 something something all in Newton, okay? So now these two things together, we have resolved it in components. Our answer has finished. But for you to know what we are doing, if I still want to make it like this using Pythagoras, you know what I said, that you can put this thing using this formula. So when you now know the particular direction, because it is a vector quantity, it must have a particular direction. But this ends it here, okay? Alright, but now, okay, now if you now want to go by that one, you can still check something like this. Like for instance, f of r, which I gave you here, something like this, which is a square root f of s squared plus f of y squared is going to give us square root of this side is what? 9.89 something something squared, because I'm going to check everything if I'm to press it, plus then this one is minus this man, which is minus this 6.94 all squared. You know, when you are squaring, the minus will go, okay? So at the end of the day, you square it, you square this one, you find the square root, okay? It will now give us the final answer to be 12.09 Newton, okay? It means that that's the singular direction, that bullet, that ball that was acted on every angle. That's the direction it will take. But look at the drawing. If I'm to redraw it when I want to resolve it, before I resolve it to this way, okay? To the way it will look like is going to be like this. For instance, it's going to be like this. Let me clean here. Maybe let me clean here. You clean there now. Let's have something like this. For instance, this thing is going to give me a thing like this. It's going to give me a thing like this. This is our f of s, which is equals to what? 9.89 something something Newton, like I told you. Then this direction is going to give me, which is our f of y, is going to give me equals to what? It's going to give me 6.94 maybe something Newton. You remember here now, which is 6y, I didn't put the minus. Do you know why I didn't put the minus while I'm putting this thing? Because is pointing towards the negative side. So no need of putting the minus here, but there is minus to it, okay? There is minus to it, so no need to, that's why I omitted it. It has a minus to it based on what we saw. So if you have something like this, you can now see that this is the angle. We don't know the angle yet, okay? I will show you how we get the angle. So if you want to get the angle now, having noted these two men, which is you have to find this. You have to say tan alpha is equals to tan toa is toe, opposite, toa, opposites, okay? Toa, opposite over what? Adjacent. So we are looking for among the SOHCAHTOA, the one that will meet these two. So tan alpha is opposite, which is this, and this one is also our f of y, which is what? 6.94 all over toa, opposite over adjacent, which is 9.8, which is 9.89. Okay, so it will now give us, you now have, this is for tan alpha, then alpha itself will now be tan inverse, which is tan crossing sign, tan inverse of the whole of this value, tan inverse 6.94 over 9.89. Okay, now you now have alpha itself, because this is tan alpha is itself will give us 35.1. So it means that this side will now be 35.1. Okay, it means that assuming this side now, this angle, assuming it is phi. So you can now say phi is equals to what? Phi is equals to 90 minus alpha. Okay? Phi is equals to 90 minus alpha, which is 90 minus 35 point. No, if you want to, yeah, 90 minus alpha. Yeah, 35.1. Okay? 35.1. So if you want to know this side, sorry, this side, it is the angle is 35.1 here. 35.1 here. Okay? So if you want to know this side, we don't know, which is our phi. 90 minus alpha, which is 90 minus alpha, it will now give us something like 54.9 degrees. If you want to know this angle. Okay? Alright, so if you have any question, you can send it to my this thing so I can answer it online with you, okay? If you have any questions, send it in, okay? Send it in.